Hi, welcome back. Today's discussion it will be all about the frame of reference. I have some interest to look about this type of discussion because it plays some vital role under the physical intuition that always whenever we want to do anything we just take the frame of reference. Frame of reference, what it exactly in physics, this will be my key intuition in this discussion. So let me start here. Okay, frame of reference. What this means in physics? Actually, frame of reference it's nothing as it's a view of the measuring things. In which view we are basically to measure the things. That's what this frame of reference means. Frame of reference is view of in which view of measuring the things we just call it's known as a frame of reference. It's very important to look about this concept in physics that in which view we are just basically measure the things that's known as a frame of reference. How it exactly works under some different physical intuition and what it exactly means in the exact passion, how we can understand this concept fully. I will just make the use of example. By that we will try to visualize this everything and how it works under some greater physical intuition that we see. See here, suppose for instance if I will take the three things here, the first most thing that I will just choose, that's a ground. And one thing more here, there is a car. Suppose this is car. It just moves. And suppose there is an aeroplane, okay? Now, if there is any observer, any person who just view this all such and according to this observer who has some physics apparatus to measure the speed of this car and the speed of this aeroplane. For example, the speed of this car is, yes, in case first we just see there is some observer who has with some physics apparatus just measuring the speed of car as well as the speed of aeroplane, but who is being sitting in the rest frame relative to the ground. We assume that ground in which we are going to be live is at rest, isn't it? So anyway, if there is an observer who is being measuring this the velocity of these two checks, that's an aeroplane and the car. Suppose according to this observer, this car it moves with the velocity of 50 meters per second in this way, and this aeroplane it just move with the velocity of 250 meters per second, but in this way. In case first, what we are just try to do here, I take Earth as a frame of reference, ground as a frame of reference, because observer who is being sitting at ground, who is being sitting in a ground, isn't, and observer is being stationary relative to this ground. Very important. And under this observation, under this view of measurement, observer feels that this car it moves with the velocity of this much, and this moves with the aeroplane it just moves with the velocity of 250 meters per second, isn't it? So it's a quite shaky speed of this aeroplane, but anyway, what we just feel here, this is basically the frame of reference. We just take the frame of reference as ground because we just view all such measurements with respect to ground. Observer is being staying ground at rest relative to it. So the stationary observer at the ground just feels that this aeroplane it moves with this much speed and this car it moves with this much speed but in this way. So it it's actually all such we are going to view this measurement with respect to ground. Now, if we will change our frame of reference, changing the frame of reference means that changing the view of measurement. We will measure this all such here, but on a different view. Is in case first ground was at rest, car was moving with this much and aeroplane was moving with 250 meters per second in this way. So if we now change our frame of reference, changing the frame of reference as I told you before, changing the view of measurement, because in which view we just measure the things, that's the frame of reference is called so far. Now if we just change our frame of reference, for example in the case second, in case second, now we just use the car as a frame of reference. Now observer who is being sitting inside the car and measuring this all such. But car itself moves according to the first point of observation. Now what we are going to do, observer who is being sitting inside the car, in the car frame of reference, observer is basically at rest relative to the car. Observer is at rest relative to the car, but according to first point of observation, in the frame first we just take its ground, but the car it basically moves with this much of velocity in this way. But in the first type of observation, to measure the things, observer is being sitting inside the car's frame. Now we have to measure this all such here once more. It's just like an experience. We feel that sometimes we are inside the train and train is moving. We just see the things around. They are going to move backwards relative to the motion of car or the motion of any moving object. Is it? So if we will just feel that sort of experience here, same is the case, car is basically moving with this velocity according to first most point of observation that we take the ground in the first case. Now in case second, we are basically inside the car and just try to make all such measurements once more. Now in the case second, what observer will feel that ground it will be exactly move backwards with the 50 meters per second. This is where from I just mentioned that the ground it will basically move with this much of velocity, but in this way. It's all experience that when we are inside any moving vehicular object and we see the things around, they just move backwards, isn't, with the same speed as that of the object moves at times, isn't? So this is actually where we can feel this all such, and it's true indeed. It depends upon in which view we are just measuring things. In case second, the observer is being sitting in the car's frame. Now at the same time, if for this point of observation, what will be the velocity of this Boeing aeroplane? Aeroplane initially moves with this much of speed, but if we just view this measurement from by taking the reference frame as observer is being sitting inside the earth, yes, under this way, what will be the velocity of this aeroplane? Yes, see, for any observer being sitting in any moving object, sees the things around him moving backwards with the same speed, isn't, as that of the object moves. But the things which are basically at rest, as an observer sees in an outside surrounding, are basically at rest. But if there is an object that itself moves, then from this point of observation we have to add that much of speed also. Very simple here. For example, for this observer who is at the car's frame, just look how with velocity actually this aeroplane moves. What actually the observer will feel here? Yes, aeroplane itself moves with a velocity of 2 meters per second, but car it basically moves with this way with this much of velocity, and from this point of observation we'll see the things around. If this observer will see the things around, they will just try to move backwards. If car moves this way, aeroplane moves this way, and what will be the velocity of this aeroplane from this point of observation? It will not 250, but we have to add this much of, because ground was basically at rest. But from this point of observation, we will feel that ground will move exactly with the same speed as that of car because ground is at rest. So, but in this, how we can measure the velocity, this velocity of this aeroplane from this point of observation? It itself moves with this much of velocity, but if it moves this way, but aeroplane moves this way, we have to add this much of velocity from this point of understanding, is it? So, this will be as 300 meter per second. By this way, we got another view of measurement by putting the observer in the Earth's frame. Now, there is one more pending class of measurement, that if an observer who is being sitting in the aeroplane frame. So, let me just shift this observer being sitting in this. It's not then this observer who is just taking the fly this aeroplane, but have some physics apparatus to measure this all set. Now, from this point of view, if the observer is being now in aeroplane, motion, actually aeroplane is at rest relative to this observer, but aeroplane basically moves with this much of velocity. Now, in the third, what will be the velocity of this car and the ground is, see, aeroplane, it moves this way, the observer who is being sitting in the rest frame of any moving object will see the things around him moving with the velocities, isn't it? According to this observer, car, it is basically in motion, but ground will be also in motion. According to the observer who is being sitting in the frame of aeroplane, will feel that the ground, it will basically move this way with the velocity of 3 meter, 250 meter per second. From this point of observation, if observer is being sitting in an aeroplane, sees the things around him, and what sort of measurements we will got here, from this point of observation, ground is moving 250 meter per second, is it, relative to this observer. This is the first observation from this way, as taking the frame of reference as aeroplane. But this object, it itself moves with car, basically moves with the velocity of 250 meter per second. But according to this observer, car will basically move 250 plus 50. That's 300 meter per second. By this way, we got the views of different measurements, and we got the three classes of measurements. We got the first measurement taking the ground as a reference frame, accordingly taking the car as a reference frame. In case third, we take aeroplane as a reference frame. We just view the types of measurements, and basically what we are going to do, we just ignore this type of measurements. Under physical intuition, these are the true measurements. No issues there are, but we just prefer this type of measurement because at ground, any point of observation seems to be rest relative to the ground. That's indeed, very simplest approach to go with the things. That's why. Otherwise, these two ways of measuring the things are true under the physical intuition. No issues there are, but we just make the preferred way of just taking this point of observation under greater physical intuitions. That's why. So this was all about what exactly this frames of reference means to us and how we can carry the measurements while on sitting in different frames of reference. I just picked an example. If you have any confusion regarding this, you can just comment on this comment box. And if you have any confusion, any question, any query regarding this, you can. And if I have just make any error about this context, please you can mention that thing also. Thank you.